Welcome back to Universe Intelligence, dear explorer of science. Are you ready for another mind-bending adventure? Yes? Let's go. Let's speak today about consciousness. Why are there not more people talking about consciousness? This question has puzzled philosophers and scientists for centuries. It is the subjective experience of awareness, the feeling of what it's like to be you. Consciousness encompasses our thoughts, emotions, sensations, and perceptions. Despite advances in neuroscience, the origin and nature of consciousness remain a mystery. How does the brain, a physical organ, give rise to the subjective experience of being? This question lies at the heart of the mind-body problem. Some believe consciousness is a product of the brain's complexity, emerging from neural networks and electrochemical signals. Others propose that consciousness is fundamental, a basic property of the universe, like space and time. Could our consciousness be intertwined with the very fabric of reality in ways we're only beginning to understand? This question leads us to the intriguing realm of quantum physics. Quantum physics, developed in the early 20th century, revolutionized our understanding of the universe at its most fundamental level. It introduced concepts that were not only groundbreaking, but also deeply perplexing, challenging the very fabric of classical physics. It governs the behavior of atoms and subatomic particles, the very building blocks of matter. The quantum world is strange and counterintuitive, defying the classical laws of physics that govern our everyday experiences. Unlike the predictable motions of planets and pendulums, quantum particles behave in ways that seem almost magical. One of the key principles of quantum physics is wave-particle duality, a concept that defies our everyday logic. Subatomic particles, like electrons and photons, can exhibit both wave-like and particle-like properties. This means they can spread out like waves and yet also collide like particles. This duality challenges our classical intuition, where something can be either a wave or a particle, but not both. In the quantum realm, these distinctions blur. Another key concept is superposition, which further complicates our understanding. In the quantum world, particles exist in a probabilistic state, a superposition of all possible states, until a measurement is made. This means a particle can be in multiple places at once, or in multiple states simultaneously. Imagine a coin spinning in the air. It's neither heads nor tails until it lands. This is a simple analogy to grasp the idea of superposition. Similarly, a quantum particle exists in all possible states simultaneously until it is observed. The act of measurement collapses these possibilities into a single reality. Quantum physics reveals a reality that is fundamentally uncertain and probabilistic, a far cry from the deterministic clockwork universe envisioned by classical physics. This uncertainty is not just a limitation of our measurement tools, but a fundamental property of nature. This uncertainty has profound implications for our understanding of reality, including the role of consciousness. It suggests that the observer plays a crucial role in shaping the reality they observe, intertwining the act of observation with the fabric of the universe itself. One of the most perplexing aspects of quantum physics is the measurement problem. The act of observation seems to play a crucial role in collapsing the wave function of a quantum system, forcing it into a definite state. This is known as the observer effect. Before measurement, a particle exists in a superposition of states, a blur of possibilities. However, when we observe the particle, its wave function collapses, and it assumes a definite state. The very act of observation seems to influence the reality we observe. This raises a profound question. Does consciousness cause the collapse of the wave function? Is the observer's mind, the subjective act of observation, what transforms the quantum world from a realm of possibilities into a concrete reality? Some physicists believe that consciousness is essential for the collapse of the wave function. Others argue that consciousness is irrelevant, and other physical processes are responsible for the collapse. The measurement problem remains one of the biggest unsolved mysteries in quantum physics. Quantum entanglement is one of the most bizarre and mind-boggling phenomena in quantum physics. It describes the way two or more particles can become linked, even when separated by vast distances. When two particles are entangled, they share a special connection. Measuring the state of one particle instantly determines the state of the other particle, no matter how far apart they are. This instantaneous correlation seems to violate the principle of locality, which states that an object can only be influenced by its immediate surroundings. Einstein famously called entanglement spooky action at a distance because he found this instantaneous correlation deeply unsettling. It seemed to contradict his theory of special relativity, which states that nothing can travel faster than the speed of light. However, countless experiments have confirmed the reality of entanglement. Entangled particles do indeed influence each other instantaneously, regardless of distance. This strange connection has profound implications for our understanding of the universe and the potential role of consciousness. Section 5. Consciousness and Quantum Mechanics, Bridging the Gap. The strange world of quantum physics, with its observer effect, measurement problem, and entanglement, has led some scientists and philosophers to speculate about a possible link between consciousness and quantum mechanics. This intersection of fields is not just a theoretical curiosity, but a profound question that could reshape our understanding of reality. Could consciousness, long considered a mystery in the realm of classical physics, find a home in the enigmatic world of quantum mechanics? The idea that our thoughts and awareness might be tied to the fundamental workings of the universe is both thrilling and perplexing. This question has sparked intense debate and generated fascinating theories. Researchers from various disciplines are coming together to explore these possibilities, blending neuroscience, physics, and philosophy. Some prominent physicists, including Eugene Wigner and John von Neumann, propose that consciousness might be the missing piece of the puzzle, the factor that collapses the wave function. Their groundbreaking ideas have inspired a new generation of scientists to delve deeper into this mystery. The factor that collapses the wave function. This idea, known as the consciousness causes collapse interpretation, remains controversial. Critics argue that it lacks empirical evidence, while proponents believe it offers a compelling explanation for the observer effect in quantum mechanics. Other theories explore how quantum processes might be occurring within the brain itself. These theories suggest that the brain's complex neural networks could be leveraging quantum phenomena to enhance cognitive functions. Could the brain be a quantum computer, utilizing quantum effects for information processing? This concept opens up new avenues for understanding how we think, learn, and perceive the world around us. This is the central question driving the field of quantum cognition. Researchers are investigating whether quantum mechanics could explain the brain's remarkable capabilities, from memory to decision-making. While a definitive link between consciousness and quantum mechanics remains elusive, the exploration of this intersection continues to generate exciting research and mind-bending possibilities. As we push the boundaries of science, we may one day uncover the true nature of consciousness and its connection to the quantum world. Section 6. The Orchestrated Objective Reduction Theory. One of the most well-known theories proposing a connection between consciousness and quantum mechanics is the Orchestrated Objective Reduction, or Orch-OR theory, developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. Penrose and Hameroff suggest that consciousness arises from quantum computations occurring within microtubules, tiny structures found within brain cells. Microtubules are cylindrical protein structures that provide structural support to cells. According to Orch-OR, microtubules act as quantum computers, with quantum states existing in superposition. When these quantum states collapse, they give rise to moments of consciousness. Penrose and Hameroff argue that this process is orchestrated by the brain's structure and dynamics, hence the name Orchestrated Objective Reduction. The Orch-OR theory is highly controversial, with many physicists and neuroscientists skeptical of its claims. However, it has stimulated research into the possibility of quantum processes occurring within the brain and their potential role in consciousness. Section 7. Documentaries and Research, Exploring the Quantum Consciousness. The intriguing connection between consciousness and quantum physics has captured the public imagination, inspiring numerous books, documentaries, and research initiatives. Documentaries like What the Bleep Do We Know? And The Quantum Activist explore these themes, interviewing physicists, philosophers, and spiritual teachers. These films have sparked widespread interest in the potential for consciousness to influence reality. Scientific research continues to probe the mysteries of consciousness and its potential connection to quantum mechanics. Studies on quantum effects in biological systems, including photosynthesis and bird navigation, suggest that nature may already be harnessing the power of the quantum world. Research on microtubules inspired by the Orch-OR theory investigates whether these tiny structures exhibit quantum properties. While the evidence remains inconclusive, the pursuit of these questions pushes the boundaries of our understanding. Section 8. Philosophical Implications. Redefining Reality and Free Will. The potential for consciousness to play a role in shaping reality raises profound philosophical questions that challenge our fundamental assumptions about the universe and our place within it. If consciousness does indeed influence the collapse of the wave function, as some interpretations of quantum mechanics suggest, then our minds are not merely passive observers of reality but active participants in its creation. This has profound implications for our understanding of free will and determinism. If reality is not a fixed objective entity, but rather a fluid, dynamic construct shaped by consciousness, then the nature of reality itself is called into question. What is the nature of a reality that is not independent of the observer? This idea suggests that our perceptions and thoughts could be integral to the very fabric of existence. These questions delve into the heart of metaphysics and ontology. The exploration of quantum consciousness, while still in its early stages, has the potential to revolutionize our understanding of the universe and ourselves. It opens up new avenues of thought, challenging long-held beliefs and encouraging us to explore the unknown. It challenges us to reconsider the relationship between mind and matter, subject and object, and the very nature of what it means to exist. As we delve deeper into these mysteries, we may find that the answers lie not just in the external world, but within the depths of our own consciousness. Section 9. The Future of Quantum Consciousness. Unraveling the Mysteries. The quest to understand consciousness and its potential connection to quantum mechanics is a journey into the unknown. While definitive answers remain elusive, the pursuit of these questions continues to drive scientific inquiry and philosophical debate. Future research may reveal the existence of quantum processes within the brain, providing evidence for theories like Orch-OR. Advances in quantum computing may shed light on the brain's computational capabilities and whether it utilizes quantum effects for information processing. The exploration of consciousness and its relationship to reality is a journey that transcends disciplinary boundaries. It requires collaboration between physicists, neuroscientists, philosophers, and psychologists, all working together to unravel one of the greatest mysteries of existence. As we delve deeper into the quantum realm and unlock the secrets of consciousness, we may discover that the universe is far stranger and more wondrous than we ever imagined. The journey of discovery is just beginning.